Okay. We got our second section of chapter 8. And this deals with the Pythagorean theorem and the converse of the Pythagorean theorem. Okay, what you're going to notice here is the Pythagorean theorem is uber useful. You will find that you're going to be dealing with it not just to find triangles. It's going to be part of the trig section, which is right triangles, that's all. But you're also going to deal with it in areas. You're going to deal with it in volumes, circles. For my money, if you can come out of geometry having an understanding of triangles, circles, you're going to be okay for the rest of your math lined up. Okay? Okay. Pythagorean theorem and its converse, the resources today. The notes I provide, chapter 8, pages 1 to 5. Good examples again. Also goes over what are known as Pythagorean triples. Natural whole numbers for right triangles. You'll see it when you get there. There's a few like square roots. Don't have to memorize them, but the more you use them, the more comfortable you are with them, and it's going to make it easier. I'll explain more in a second. And also your PowerPoint, okay? Chapter 8, section 2. So let's go over what we're dealing with. The Pythagorean theorem is simply a method that we use to determine an unknown, a missing side of a right triangle. And it has to be a right triangle. That's why I went with the lime green underline, okay? When we look at a right triangle, let's review. The legs are the two sides that form the right angle, okay? Those are called A and B. That's how we label them, okay? And it doesn't matter which is which. So the legs are A and B. The hypotenuse is C. It is always C. It is never anything but C. The hypotenuse is the side that is opposite, across from the right angle, okay? So basically what Pythagorean theorem says is the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. There are multiple proofs for this and examples. Please, if you have a scintilla of interest, Google. You'll find a bunch of them. Some are interesting, some are, hey, that's great. Let's, can I get a cookie? So we go from there. But that's that. We'll get into examples here in a second. Next, the converse of the Pythagorean theorem. Okay? Now, this is using the Pythagorean theorem to show that, yes, this is a right triangle. No, it is not a right triangle. It's an obtuse triangle, or it's an acute triangle. Okay? But before we even get into that, the one thing we do have to remember, and we did deal with this, okay? If you are given 3 numbers and asked, what kind of triangle is this? First check to see if those can be the sides of a triangle, okay? Remember, add 2 together, they have to be bigger, greater than or equal to, bigger than the third. So, okay? So if you've got 3, 4, and 5, is 3 plus 4 greater than 5? Yes. Is 4 plus 5 greater than 3? Yes. Is 3 plus 5 greater than 4? Yes. You have a triangle, or the possibility of a triangle. Then you can use the theorem, which is, for this, you're going to be given 3 numbers, and I'll go through the example here. Always make the largest of the numbers C. Okay? So, square the 2 smallers and add them together. If they equal the third number squared, then it's a right triangle. If you square and add the 2 smaller numbers and it is smaller than the largest squared, then it is an obtuse, because that one bigger one opens wide. Okay? And then if the 2 squared and added together are larger than the larger of the number squared, then it's acute. Okay? Because you kind of see it squeak together. Okay? This is a good page to mark when I do your photos, because there's good information on this. Okay? Let me grab some pens here. Oh, you got it. Okay, I'm going to take all of those, and that. What the heck? Oh, I got pens galore here, and I probably still don't have enough. Okay? Okay, here we go. I have 5 problems dealing with the Pythagorean theorem. Okay. And there we go. We have pens. Sorry, wasn't prepared. Okay, when we deal with these, I'm going to bring it closer for each one. Okay, so this is our first one. What we want to look at is what information are we given? No different than any other problem we've ever looked at. So on this right triangle, I am given the 2 legs. Sometimes, until you're comfortable with this, it's probably not a bad idea to label them. Okay, I've labeled the 2 legs A and B with the hypotenuse C. Yes, I did these because the numbers are largish. Okay? Okay, there's your equation. Okay? Square and add them together. Okay? Square root of both sides. Okay? Now, sometimes you can break it down, sometimes you can't. Okay? We can leave it like this. We can hit that square root key on the calculator. And that is the answer. Okay? Remember, it's an irrational number, so it's going to be approximately. Okay, there's our first one. Next, I am given the hypotenuse, a leg, and I need to find the other leg. So, same thing. List A, B, and C. Set up the theorem. Can't read my own writing. How pathetic is that? Okay. And folks, I guarantee you're going to be using your calculator a lot in this section. Okay? Okay. Now on this one, a little different. Okay? Bring it closer here so you can see. On this one, it is not a right triangle per se. It's an isosceles triangle. But remember, in an isosceles triangle, the altitude to the base is perpendicular. So this and this are each right triangles. So we're going to use one of them, and that's going to help us find that. So what that does to the 18 is split it, so it doesn't matter which you use as the right triangle. So now we've got A, B, C, and we go to work. remember to isolate the variable, perform the opposite operation. So I'm adding 9, that means I subtract 9 from the other side. Okay? Square minus square. Then I take my square root. Yes, I skipped a step or two. And there's our approximate. There's our perfect. Okay? That's that. Okay, next. I've got what appears to be a rectangle. Well, opposite sides of a rectangle are equal. So if that's 34, that's 34. 22, 22. So it doesn't matter which I use as the right triangle. Okay? I'm just going to set it up that way. Okay. Once again, set up your ABC, substitute the values you're given, calculator central, square root of both sides, hit the key if you want to. Okay? Remember, I will give you specific info on that type of thing. Okay, here, what appears to be a rhombus. Rhombuses are cool. Okay? Because the diagonals are perpendicular and bisect each other, 14 and 14, x and x, and the 4 sides outside are all equal. So I've got 4 identical right triangles. Doesn't matter which you choose. Just make sure you get C as the correct one. Oh, what is this going to equal? Okay. Okay. X squared, 14 squared, 16 squared. Okay, we're going to subtract, going to give us 60. X is the square root of 60, which we can simplify. 4 times 15 is 60, so 2 radical 15, or calculator key. Okay, so these are the problems that you're going to see a fair number of. Okay, these are also the ones you're going to see a lot of within figures, like the rectangle you just saw there and the rhombus. When you are asked to find areas and such, you will need heights which must be perpendicular. So that's a little looking ahead. Now, classify these as acute, obtuse, or right. Okay, we know how to do that. First one, check real quick. 10 plus 11 bigger than 20? Yeah. Okay, so we're in business there. Usually if you take the two smallers and they add up to be bigger than the large, you're set for the rest of it. Okay? So what we do now is just set it up. And we're going to compare. Less than. Okay? Because this number is bigger than these two added together, it's an obtuse triangle. Okay? Let's go to our next one. Okay. Is 12 plus 14 bigger than 49? No, it's not. Okay? Kind of simple. Okay, I use this example on purpose because I want to show you how to multiply those. So here we go. Okay? And yeah, they're all bigger than, okay? Okay. When you square this, square each of these terms, then multiply them together, like this. Okay? 5 squared is 25. Radical 2 squared. Any radical squared is just the number that's inside. Okay? So then you've got 25 times 2, which is 50. 150 is greater that is an acute triangle. Okay? And now our last concept over here. Yes, the obligatory word problem. Okay? Drawings. Always set up drawings. It makes life easier because you're used to seeing the picture. Okay? So now we can turn it into one. So the bottom end of a ramp is 10 feet from the base of a loading dock. Okay? If the length of the ramp is 11 feet, how high is the dock? There's our right triangle right there. Boom, boom, boom. Not a difficult problem. Okay, we had tougher ones over on the other board. Okay, x squared plus 10 squared equals 11 squared. 121 minus 100 is just 21. Square root, approximate. That's about 4.6 feet high. That's what you've got. That's the Pythagorean theorem and its converse. We're going to be dealing with those problems next. Okay? Groovy. Talk to you soon.